Hi, this is Austin with Radical STEM Tutoring, and today we're going to do some Calculus 1 optimization on geometric objects. Let's get started. So for this problem, we're going to look at a box with a square base. So its two dimensions for the bottom face and the top face are the same to make that a square. Its height can be something different. We're not going to restrict that. What we're going to do first is fix the volume to a certain value, and then find the maximum surface area, and after that we'll fix the surface area to a certain value and find the maximum volume. So to do that, we'll need a formula for both our volume and our surface area. So let's write those first. Now the volume for a rectangular prism like this, as a function of our two variables, all we do is multiply our three dimensions, length times width times height. So this would be L times L to get L squared times H. Now for our surface area, we need to add up the area of all 6 sides of the prism. So we know that our top and bottom have the same dimensions, so we're going to have 2 of L times L, or L squared. And there are 4 faces which are equal to L times H. Now first we will look at the volume being set to 12 units. This is our restriction for our optimization problem, so we can use this to solve for one variable in terms of the other. So if we divide both sides by L squared, we will see that H equals 12 over L squared. Now we can plug that into our function for the surface area to reduce it to only one variable. And if we simplify that, we'll find. Now to optimize this function, we need to take the derivative of s as a function of L and find the point where it equals 0. So to take the derivative of this function, first we would take the derivative of 2L squared. Our 2 stays out in front. Our power rule says that we bring down the exponent of 2 and then reduce that exponent by 1. Next, we have 48 times L to the negative first power, so we can use our power rule to bring down the negative 1 and then reduce that to a negative second power. And if we simplify that, we'll find. Now we want to take this expression, our first derivative, and set it equal to 0 and solve for the value of L where the derivative equals 0. If we add 48 over L squared to both sides, we'll see that 48L squared equals 4 times L. Next we can multiply both sides of the equation by L squared so that these cancel out to give us 48 equals 4 times L to the third power. To get L by itself, we'll undo this multiplication by 4 by dividing both sides of the equation by 4, giving us 12 equals L cubed. Now we want to take the cube root, or raise both sides to the 1/3 power to find that L equals 2.29. Since we found a value for L, we can find the value for H is equal to 12 divided by 2.29 squared, which comes out to 2.29. If we plug those values back into our surface area equation, we'll find the maximum surface area. Now you might notice, because L and H are the same, that means this is actually going to be a perfect cube. And our formula even gives that away, because this is really the same as 6 times 2.29 squared. There are 6 sides of an equal area of 2.29 squared, and that comes out to 31.46 units. This time we're going to restrict our surface area and say that it is equal to 25 square units, and then we'll maximize the volume. So, once again, let's solve for h in terms of L. We can subtract 2L squared from both sides to get that 25 2L squared equals 4 times LH. And then divide both sides of the equation by 4L to get that h equals 25 over 4L minus L over 2. If we substitute that into our equation for the volume, we'll find that our volume as a function of L is equal to 25 over 4L minus 1/2 L cubed. Now once again, we need to take the derivative of this with respect to L and set it equal to 0. Taking the derivative of this, a constant times our variable will just give us the constant back. And using the power rule on this, our constant will stay there. We'll bring down the exponent of 3 and then reduce the exponent by 1. And if we simplify this, we'll find, which we now need to set equal to 0. If we add 3/2 L squared to both sides, we'll find that 3/2 L squared equals 25 over 4. To undo this fraction multiplying the L squared, we can multiply by the reciprocal, 2 over 3, on both sides, to get that L squared equals these two fractions multiplied together. We're not going to bother multiplying it out just yet. Finally, to solve for L, we just need to undo this square by taking the square root of both sides. Now we know that L equals the square root of these two fractions multiplied together, which comes out to 2.04. Now that we have a value for L, we can find our value for H. And that comes out to H equals 2.04. Once again, because L and H are exactly the same, this is a perfect cube. So it turns out that the rectangular prism with the maximum surface area and volume is actually just a perfect cube. And if we plug these values in, we'll find that our maximized volume is equal to 8.49 units cubed. If you found this video helpful, please be sure to like it and share it. And remember, you can book an online tutoring appointment with us right now through our Facebook page. Have a radical day.